So in this example, we have a cosine of x divided by a cotangent of x plus sine squared x equals 0. And this quotient identity we're going to look for on the trig hexagon, remembering that quotients represent two consecutive vertices in either direction. So cosine divided by cotangent is equal to sine, right? Because sine has two consecutive vertices, cosine divided by cotangent. So we're going to apply that quotient identity and rewrite this as the sine of x plus 2 sine squared x is equal to 0. And this is a binomial that each term of that binomial has a sine of x in it. So we can factor that out as the greatest common factor, the GCF, leaving a 1 plus 2 sine of x as our other factor. Okay, from here, now that it's completely factored, we can use the zero product property to set each factor equal to 0 and solve for x as its own separate equation. So if I apply the inverse to both sides, x is equal to the arc sine of 0, and that's asking us to identify on the unit circle all the angles from 0 to 2 pi that have a y value, a y coordinate of 0. And those occur at 0, at pi, and since this is an inclusive interval, then one full rotation around the unit circle, which would be 2 pi. And then on this side, we're going to subtract 1, divide by 2, so sine of x is equal to negative 1/2. And again, we'll apply the inverse to both sides, so x is equal to the arc sine of negative 1/2. And that's asking us where on the unit circle, over the interval to 0 to 2 pi inclusive, has a y coordinate of negative 1/2. And in the first quadrant of the circle, we have pi over 2, pi over 3, pi over 4, pi over 6, and 0. That's quadrant 1. And sine is positive in quadrant 1, so we know our answer won't come from there, but we can find the reference angle that has a sine of 1/2, and that would be here at pi over 6, where the coordinate is root 3 over 2, comma 1/2. So from there, we can use that reference angle to reason out where the other quadrants are. So recall, all students take calculus. That's our acronym for where trig functions are positive on the unit circle. And sine is positive in quadrant 2, right, as well as quadrant 1, where all of them are positive. So now we know our solutions are going to come from quadrants 3 and quadrant 4. So if we take pi over 6 and we reflect it into quadrant 3, that would be our solution of 7 pi over 6. That's our quadrant 3 answer. And then taking our reference angle pi over 6, reflecting it in quadrant 4, that would be 11 pi over 6. And that would be our fourth quadrant solution. So this equation has 1, 2, 3, 4, 5 solutions over the interval 0 to 2 pi inclusive. And we're going to need to check those answers in the graphing calculator to make sure that they all work. So if we go to the mode, we want to first verify that we're in radian mode, which we are. And then we're going to store our answer of 7 pi over 6 as the x. And then we'll put in our original equation, which was cosine of x divided by cotangent. We don't have a button on the calculator for cotangent, so we're going to use the reciprocal identity, and instead of dividing by cotangent, we're going to multiply by the tangent. That's plus 2 sine of x, whoops, sine of x squared. Hit the wrong button there. and that's going to be equal to 0. And then we'll press enter. We get back a 1, so we see that that answer 7 pi over 6 checks. Okay, then we're going to test 11 pi over 6, store that as x, and then we'll arrow up to our equation so we don't have to retype it, and press enter, and we get a 1, so 11 pi over 6 checks. Then we'll put in 0 and store that as x, arrow up, and we get back a 1, so 0 checks. If 0 checks, 2 pi has to check, right, because they're coterminal angles. So our last answer to check is pi. We'll store that as x, arrow up, and there we go, we get another 1. And so all 5 answers to this trig equation check: 0 pi, 2 pi, 7 pi over 6, and 11 pi over 6.